Okay, let's try to solve a problem with the knowledge of potential and Gauss's law. So, from the knowledge of conductor, we know inside of conductor there's no electric field. So basically, at equilibrium, there's no electric field, since if there is electric field inside, then there's force that moves the particle somewhere. So yeah, that's the Gauss's law. That's the integral form. But if we have a symmetrical configuration, for instance, a spherical symmetric configuration, then we can basically use this. The electric field multiplied by the surface of the Gauss surface is a charge within divided by the epsilon naught, which is a constant. And of course, conservation of charge. If there's no charge putting into it or taken out of it, there's no charge changing. So also the charge will be distributed on the surface of a conductor. Basically means because the charge can freely move, so they will maximize the distance between each other. So pretty much that's what happened in the elevator. So let's see the problem. We have a charge plus Q1 at the middle, and we have a conductor shell outside, which have a total charge of plus Q2, and we want to know the charge on inside surface and outside surface, because we know that the charge will distribute it on the surface of the conductor. So we only have charge distributed here and here evenly. So if we could take a Gauss surface here, which is inside of the metal, thus we know that the electric field is supposed to be 0. So we know from the Gauss's law, if that is 0, then the Q within inside is 0. Q within inside is Q in plus Q1. So Q in plus Q1 is 0. And from the conservation of a charge, which is number 3, delta Q is 0. So we know that previously it's like Q2, but if it distributed on both surfaces, will be Q in plus Q out. So we have Q in plus Q out is Q2, and solve those two equations, we'll end up having Q in equals to negative Q1, and we have Q out equals to Q1 plus Q2. Yeah. So if I want to make the problem more complicated, or I can just add another shell. You just do the same whole procedure. Just take a Gauss surface in the metal and try to add all the charge together to see if it's 0, and then use a conservation of charge to calculate the outer shell, and keep on going. Yeah. And also, if you get confused on the Gauss's law, the speech or the part will be uploaded online. It's called Gauss's law. There will be details in it, and also the surface of conductor thing, they will be in the knowledge of a conductor.